Hello, and this is Muhammad bin Muhammad here to talk about area, which is under the topic of math. So the three shapes I will be talking about is square, rectangle, and triangle. Let us proceed to the square first. Now this is the basic shape of the square. The properties of the square is that it has four equal sides, meaning this side, this side, this side, and this side are equal. In square, the height of the square, the height of the shape, and the length are equal. That's making a square. So the area formula of the square is height times its length. An example, the height given is 2 cm and the length given is 2 cm. So the result area for this square is 4 cm square. Now let us proceed to rectangle. This is the basic shape of the rectangle. Now the properties of the rectangle is that it have equal opposition sides, meaning this side and this side are equal, this side and this side are equal, but this side and this side are not equal because this side isn't opposed to this side, meaning its height and its length are not equal, differ to the rectangle. So the area formula of the rectangle is height times its length, same as the square. So here's an example. The height of the rectangle is 2 cm and the length is 4 cm, which result the area of the rectangle is 8 cm squared. Now let us proceed to the triangle. Now this is the basic shape of the triangle. Triangle is a polygon with 3 sides, and some of the known triangles are equilateral triangle, isosceles triangle, scalene triangle, right angle triangle, obtuse angle triangle, and acute angle triangle, which is own different properties. Now let us go to the first, equilateral triangle. The properties of this equilateral triangle is that each of the sides of this triangle are equal, meaning angle inside this triangle is equal. So the area formula of this triangle is that 1/2 times its height times length. An example, 1/2 times 2 cm times 2 cm equal to 2 cm squared. That will be the area of this equilateral triangle. Next, isosceles triangle. Now isosceles triangle differ itself from equilateral by having only two equal sides, not 3. So this side and this side equal, but this side isn't equal to these two sides, meaning only 2 angles in this triangle are equal, but this triangle is not. The area formula of this triangle is 1/2 times its height times its length, same as the equilateral triangle. An example, 1/2 times 2 cm times 1 cm equal to 1 cm squared. Now next we go to scalene triangle. Now scalene triangle is not differ itself from equilateral and isosceles because scalene triangle does not have equal sides, meaning it does not have equal angle. Meaning how to calculate this triangle? So we must first divide it into 2 parts, part 1 and part 2, and then we can calculate normally. So the first part will be 1/2 times its height and its length, and the second part is also 1/2 times height and its length. An example, 1/2 times 2 cm times 2 cm plus this area of the triangle, which is 1/2 times 2 cm times 1 cm, which will result 3 cm squared, which is the area of this scalene triangle. Now let us proceed to the right angle triangle. The properties of the right angle triangle, it have a 90-degree angle, which will be shaped around here. Now right angle triangle can be either isosceles triangle or scalene triangle, because its length and height may equal to each other. So the area formula of this triangle is 1/2 times its height times its length. An example, 1 over 2 times 2 centimeter times 2 centimeter equal to 2 centimeter square. That's the angle, that's the area of this right angle triangle. Next, an obtuse angle triangle. The properties of this triangle is that the angle inside has more than 90 degree, meaning it will have different in height and length, this height and this length. So how to calculate the area of this triangle? By using the formula half times height times length, only can use on the 90 degree angle triangle. So in this part, we need to use the scaling formula, which is divided this in two triangles, which is part 1 and part 2. But part 1 will include this full side triangle, while part 2 will include this one invisible triangle. Now, how to calculate the area of the triangle? The formula of this triangle is that half of height times length minus with this invisible triangle, which is half times height times length. An example, half times 2 cm times 3 cm in length, which is the total of 2 cm plus 1 cm, minus the half times 2 cm times 1 cm, which is the area of this invisible triangle. We can now get the area is 2 cm squared, which is the area of this obtuse triangle. Next, acute angle triangle. Now, acute angle triangle have an angle less than 90 degree, meaning it will also have different in height and in length. Now, the area formula of this triangle is similar to scaling triangle, which is 1 over 2 times 2 cm height times length 2 cm in length plus with 1 over 2 times 2 cm height plus times 1 cm in length, which is equal to 3 cm squared. Now, have you all learned the lesson? Let us proceed to the exercise. Find the area of this shape. Now, this shape is not a rectangle, not a square, not a triangle. This is a complex polygon. Now, in order to find the area of the shape, let us use the lesson that we learned before. So, we know that this complex polygon is made out of two types of shape. The lesson that we learned are rectangle and triangle. From that, now we can calculate the area of the shape. First, the area of the rectangle. Given that this part is a rectangle which has we have four sides, we can assume it's either square or rectangle. For now, let's assume this is a rectangle. So to calculate the area of the rectangle is 3 cm in length times 3 cm in height, which is equal to 9 cm squared. Now, since we get this area of the rectangle, now let's get the area of the triangle. As you see here, there are no height and length given for this triangle. So how do we calculate it? Use the basic math to get the answer. So the height of the triangle is, we take 5 cm from the total length minus with 3 cm from this rectangle we just calculated. So that leaves us 2 cm for length in triangle for this height. Given the 3 cm length for the rectangle and 1 cm extra for this side, we total up to 4 cm. Now we are given 2 cm in height and 4 cm in length, which can total up to, which can use the formula of the triangle. 1 over 2 times 4 cm times 2 cm equal to 4 cm squared. So now we get the area of this rectangle, and we also have the area of this triangle. Now we can total up to get the area of this shape, which is 9 cm squared times 4 cm squared equal to 13 cm squared. That's all I have today. So thank you, and that's all.
Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muslim. I'm a student of Kuala Lumpur University Malaysian Institute of Aviation Technology, and today I would like to teach you and illustrate about how to find the area of trapezoid. I will try to make it easy to understand, but first of all, we should know what is a trapezoid. The definition of a trapezoid. Four sides are shaped with a straight side that has a pair of opposite sides parallel. The sides that are parallel are called bases. The other sides are legs, which may or may not be parallel. And next, I will talk about the formula. The formula we use to find the area of a trapezoid is half times h times b1 plus b2. H is the height. The height always the straight line up and down distance between the top side of the trapezoid and the bottom side. So let's get started with the first example. So we have a trapezoid with the bottom side with 8 cm and the B1 6 cm, and the vertical distance between a top and a bottom is 10 cm. Alright, there is the formula. Area equal half times h, all multiplied by 1 b1 plus b2. Half times 10 equal to 5, 6 plus 8 equal to 13, so 5 equal to 13 is equal to 17 centimeter square. I have another example just to make sure that you understood or not. Here you are. Look this example. This example has a note. The note says in the middle of a trapezoid is a square. It means all sides have equal length. The given B1 is 5 cm, B2 equals C plus 5 plus 4, C plus 5 because this side equal to this side, plus 4 equal to 12 cm. The height 5 cm. This is the formula. Area half times 5 multiplied by 5 plus 12. 5 plus 12 equal to 17. Half times 5 equals 2.5. So 2.5 times 17 is equal to 42.5 centimeters square. That's all. Thank you for watching. See you then.
Hello everyone, my name is Abdullah and today I'll be talking about the parallelogram. The parallelogram, what is it? The definition of the parallelogram: a four-sided flat shape with straight side where opposite sides are parallel. Also, opposite sides are equal in length. So, if we assume this is side A, B, and this is C, D, so AB will be parallel with CD. That means no matter how much we extend the side, they will never intersect in a certain point. The opposite sides are equal in length, so AB is equal to CD in length, and that goes to the other opposite sides. Opposite angles are equal. That means if we assume that this is angle A and this is angle B and this is angle C and this is angle D, the opposite angles will be equal. That means A is equal to C and B is equal to D. The parallelogram properties: the diagonals bisect each other. Consecutive angles are supplementary. That means angle A and D and C here are equal to 180 degrees. Opposite sides are equal. That means AD is equal to BC here. DC is equal to AB here. And opposite angles are equal. As we've seen here in the configure, 70, the angle here is equal to the opposite angle here, which is 70. And the angle here, which is 110, is equal to the 110 in the opposite angle. what is the formula for the area of the parallelogram? Area is equal base times height. So this is not our height. The height is the point that we drop from here, or from the middle of the shape, or from anywhere, even out of the shape, but it have to intersect with the base with a 90-degree particular angle. So in the example was given, the formula is A equal to B times H, which is base times height. A is equal 12, which was the base in the previous example, and 5 was the height here. So A is equal to 60 centimeters square, because it's the area. That's another example, but here we have the height out of the particular shape, but we have the particular angle that we can use. So the formula, it's as usual, A equals to B times H equals 7, which is the base. The base here, because it extended from the 7, that's why we chose this as a pair of the height. So 7 times 4 base times the height equals 28 units square, because it's a height. And here we have another example of a height inside the shape. As we know that the B equal to H, base times height, is equal 4 plus 2, which is the base, times 5, which is the height here, is equal to 30 centimeters square. So here is top of the parallelogram that not a lot of people like to see, because here we would have two parallelogram in each other. So here we have 10. If you assume this is the base, we have here 10. The height is unknown, and we can't work with that. So let's go to the other side here. Here we have the base is 14, the height is 8, so we can work with this. So A equals 14 times 8 equals to 112 units. So we know here that the area is 112 units. So from the formula we have A equals BH, we substitute. We know the area equals to 10H. So we have one unknown here. So we will divide with 10 here, and we will divide with 10 here. So the height is equal to 11.5. The area here is equal to 11.2 units. Our height can be anywhere in the shape as long as it's bare with the base. Like it can be here, it can be in the middle of the shape, it can be in the end of the shape, it can't be anywhere, but it has to bear with the base with a particular angle of 90 degree. Thank you for watching. I hope you enjoyed.
Assalamualaikum. My part is circle. So this is a perfect circle, for example. So how do we calculate the area? The formula given is pi r square. So what is r? R is the radius from the center of the circle to the edge of it. This is what we call a circle. So what if from the one edge to the other edge there's a line passing through the center of it? This is what we call a diameter. Okay, this is a diameter. So another part of a circle is a circumference. Circumference can be calculated by 2 pi r. So where is exactly the circumference? Circumference is the edges of a circle. All of here, that is the edge of a circle, and it is what we call a circumference. So done by that. Another part of a circle is what we call a chord. A chord is when just a part of a circle on the edge of it. For instance, this is the chord of a circle from point A to point B. That is what we call a chord. So another part of it is a sector. From one circle here, this from the center, this here, just a part of it. This is what we call a sector. So taken from here. Okay, how can we calculate it? The sector of a circle. So the given formula for the area is theta over 360 degrees times by pi r squared. You can use this formula, or another formula of it for calculating the area: half r squared theta. So what exactly is theta? We know that r is a radius, and what the theta is actually the degree of here of the sector. So let's say this area is 60 degrees. We must not use 60 degrees. We must first convert the degree into radian. So for using the previous formula, theta must be in radian form. Okay, thank you.
Hello, I want to teach about the area of ellipse. So we know that ellipse has an oval shape that is kind of like circle, but the circle has same radius when ellipse has two different radius, that is A and B. Okay, let's see the formula for the area of ellipse. We know that the area of circle is pi r squared, but since ellipse has two different radius, so it's become pi times A times B. A lies on the major axis, that is the distance from center to vertex, while B lies on the minor axis, that is the distance from center to co-vertex. Okay, let's see the equation of ellipse. It's simple actually. The equation is x squared over a squared plus y squared over b squared equal to 1. So this is the only equation for the ellipse. Let's see the example to get more understanding about the area of ellipse. Okay, example 1. Given that area of the ellipse x squared over a squared plus y squared over 25 equal to 1 is 30 pi. What is the value of a? Okay, we know that the area is 30 pi, where the formula for the area is pi AB. So 30 pi is equal to pi AB. Since both have pi, we can cancel them off. So we got AB is equal to 30. From the question, we know that y squared over b squared here. So 25 is the b squared. To find b, we need to square root the 25, and we got it as 5 equal to b. So let's insert the b here. So we got a times 5 is equal to 30, and the answer a is equal to 6. Okay, let's see another example. This time, it's given that radius of the circle. Okay, what is the radius of the circle that has an area equal to that of the ellipse below? Given that x squared over 64 plus y squared over 4 equal to 1. So we know that this is a squared and this is b squared. So to find the area of the ellipse, we need to find a and b. So like before, we need to square root the a squared, that is 64, to get a equal to 8, and square root of 4 to get b is equal to 2. So now we can use the formula area equal to pi times a times b. So we got the area of the ellipse is 16 pi. The question asks, what is the radius of the circle that has an area equal to that ellipse? We know that formula for the area of circle is pi r squared. So 16 pi is equal to pi r squared. We can cancel the pi again. So we got 16 equal to r squared. To find r, we just need to square root the 16 and we got that 4. So the radius of the circle is 4. Okay, let's see the last example. This one is the quite easy one, since it's direct. So we need to find the area of this ellipse. We know that the measure axis is 10 plus 2 equal to 12. So to get A, we need to divide by 2. So we got A is 6. Okay, next we need to find B. The minor axis is 4 plus 2 equal to 6. To find B, we need to divide it by 2 again. So we got B is equal to 3. Lastly, we use the area formula, that is pi times A times B. So we got it as 18 pi unit squared. Okay, that's all from me. Thank you.
Hello everyone. Okay, it's now my turn to teach you guys. Previously, a few of my friends has teach you how to calculate area of a many sheet. So now my turn to teach you how to calculate the area for the wing area. As you can see in the picture I show in the video, actually the picture of the wings. I thought you all guys must have known what is the wing, right? What is the wing? It's like a bird wing, but it's for aircraft, not for birds. Okay, wing area. Wing area is the projected area of the platform and is bounded by the leading and trailing edge and the wing tips. Okay, what is the leading and what is the trailing edge? Let me tell you. The leading edge is the upper side of the wings, while the trailing edge is the lower part of the wing, and the wing tips is the end of the wing, here and also here. So it's just simple to calculate the wing area. Just so simple and just like it's finished. That's all. Okay. To calculate the wing area, it's necessary to know the meaning of the term span and chord. Okay, what is span and what is chord? Let me tell you. The span is the length of the wing from the wing tip, from this wing tip until this wing tip. Let me show you the picture just now. Okay, the span is from this wing tip until this wing tip, while the chord is the average width of the wing from leading edge to trailing edge. The average width here from the leading edge to the trailing edge. Okay, if the wing is this important episode. If the wing is tapered wing, the average width known as the mean chord C, denoted as C, must be known to find the area. So the formula is to calculate the wing area. The formula we use is the span times the mean chord. The S, the C. We just time both of them, the S and for the C. Okay. Next, I will tell you how to calculate the wing area for constant chord wing. Okay, constant chord wing is just as simple as the rectangular. No need to worry how hard you are to think, oh, what is the constant chord wing? Actually, the shape of the constant chord wing, as you can see below, is the simple rectangle shapes. So to calculate the area of it, just same as the area for the rectangle, the y times the h. But in aircrafted, we change a little bit. So the wing area is going to equal to wingspan here times the wing chord here. The wingspan represents the right, while the wing chord represents the height. Okay. Do you understand what I teach you now? Okay. If you don't understand now, I'm going to show you the example of question about this topic that I teach you right now. So the example, like you can see, it says find the area of the tapered wing span is 50 feet and its mean chord is 6 feet 8 inch. So how you going to calculate it? Just use this. Just use the formula as I showed up. It's simple as the area equal to the span times the chord. As we said above, the span value is 50 feet. Just add into the row solutions. And the mean chord is 6 feet 8 inch. Just add it into, just change it. If you don't know how to change it, just use the calculator. It's a symbol over there that how to change it. Just press that and you're going to get 6.67. So when 15 times 6.67, you're going to get 330.5 square feet. That's it. It's simple. Just in the blink of the eyes, you can get the answer. No need to worry. It's just very simple, just as simple as eat an atom. Okay, I think it's done for me right now to teach you guys. Okay, see you next time. Bye.